right. Well, let's get started here. Yeah, I'm very excited to be with everybody today and talk about this topic of our a tool that we've developed here, this overall risk assessment. But let's get started here with a little intro about me. So if we can get this to advance. So I work at General Mills, but let me tell you a little bit of background about myself. So I'm here in Minneapolis, Minnesota, but I'm originally from central Minnesota. My family's got a farm up in the center part of the state where we raise free range. We raise farm fresh vegetables. You can see me there at one point last year during the pandemic, helping out driving the tractor and doing some tillage there. I then, after working on the farm, went to the University of Minnesota to get my degree in food science. Got married, had kids. You can see I've got three great kids here, ranging from all the way as extreme as 4 years old, all the way up to 17-year-old boy there. And then you can see my little guy. So yes, there is an extreme age difference between the youngest and then the other two. So a little gap in there, but he's super fun to have around. Our dog Ollie. And then I do enjoy the weather here in Minnesota, as extreme as it is. One of my favorite things to do in the winter here is you can see I'm spearfishing. So I'm standing on a couple feet of ice and spearfish through that ice in a dark house. Also like my time in the snowmobiling, and here is my vintage 1976 John Deere snowmobile that I enjoy working on as well. So lots of fun hobbies: hunting, fishing, traveling, getting out into the outdoors there with family and friends. So a little bit about me before we get into the topic today. So I'm going to try to make this as interactive as possible. I'm going to have you interact with me. If you want to chat, if you want to, hopefully you can figure out the annotation tools as we move forward and can draw, write, use the text, whatever there, and then also come off mute and talk to me as well. So hopefully this is an interactive process. Yeah, so, talking about project management, not always do things go as planned, right? Whether that's, doing a kitchen remodel, all the way up to obviously the topic of today and plant capital and execution there. So we want to introduce you to this tool that we've worked together to develop to help us think about, how do we minimize risk? And, it's more comprehensive than just food safety, but that's kind of the area that I pretend like I've got some expertise in. So that's what I'm going to focus on. So we're going to talk a lot about sanitation, sanitary design, but it's not just about risk. It's about efficiencies, right? And trying to minimize the impact of, extra cost, extra or wasted time, those types of things. So let's do it right the first time, and let's minimize the impact to the business and to our resources. So we'll get into some detail and some examples that I'm going to share around that. So some simple objectives that we want to get across today. We've only got an hour together, but we want to at least provide awareness of this overall risk assessment tool, get you to see what it looks like at a high level and go through some examples, some basic expectations for use. How do I use it? How do I want you to think about this and interact with your cross-functional teams, that type of thing. And then request feedback for improvement. This is a relatively new tool for us, and we're really interested in what we can do to make that better and to expand its use throughout the industry, that type of thing. So here's a nice little overview. I'm not going to get into a lot of detail on this around some of the key components to this tool, but I did want to highlight, as you think about project initiation up here at the top, really starting out with identifying, hey, who's going to own the tool and help facilitate that? They're obviously not going to do all the tasks within the tool, but making sure that they're pulling in the right team members in that process. And then in here in the purple, really setting the stage by doing a great kickoff meeting, right? So focusing on risk and especially food safety from my standpoint, and talking with and setting the expectations, success criteria, all of that for that cross-functional team. So here's a snapshot of what the tool looks like at a high level. I don't expect you to be able to read this. I'm going to get into some level of detail here, but it's just a checklist and identifying team members here. So the first one here I'm going to highlight is, who we think needs to be involved in some of these key tasks. So here's a close-up of this. So let's try to utilize the annotation if we can. Can you highlight which area fits best to describe you and your relationship to the project, to your role, that type of thing? So, the first ones here are really related to the plant, and am I part of plant maintenance or plant quality, sanitation, engineering?
Karl, can I interrupt you for a moment?
Oh, yep.
Sorry, you can't see me because you're pinned right now, but are they going to have access to your slides?
Yes, I can definitely send those out. And
fabulous.
The BEMA team.
The previous slide looked really helpful.
Okay.
And then also, just to let everyone at home know, I have annotation ability up at the top where it says view options. It says you are viewing Karl Thorson's screen, and under view options. I don't know if the participants have that same level of control. Can one of the participants maybe come off mute and let us know? If the drop down that says view options, can you select annotate? Anybody?
I can, yes, I can select that.
This is a terrible smiley face, Karl, but there you go.
Oh, yes, great.
Okay, I'm going to erase that now. Okay, so everybody, what Karl is asking, I'll have him repeat that just in case you weren't familiar with the annotation tool. So I'll take myself off now.
Okay, excellent. Yeah, so if you can find that annotation tool and make a check mark next to which group you identify with, or circle it, or whatever is easiest for you, if you can figure out that annotation tool here. So here, I will show you an example of a check mark here. I'm in sanitation quality. Oops, and I went the wrong direction here. It actually does that on my presenter slide. So let me try that again. Stamp. Yeah, so I'm part of sanitation. Let me clear my drawings. Excellent. So yeah, a lot of people that are probably part of third party, right? Or OEMs for equipment or contractors. I see engineering. Excellent. Very good. That'll help me understand where to focus our discussion today as well. All right, great. It looks like some people are figuring out the annotation. So yeah, anytime during the presentation, if you want to highlight something, make a note on there, go ahead and do that. If I find it really offensive, I can erase it myself. I have that control. All right, great. So I'm going to go ahead and clear the annotations here now and move on to the next one. So thank you for that. So yeah, so it's really important that we have our cross-functional team involved, right? It takes a village to execute a project. And it's not just from a food safety standpoint, it's not just quality and sanitation. Absolutely key involvement is obviously the foundation to really good sanitation execution is good sanitary design and thoughtfulness around how to minimize those risks and to make it as an efficient as possible process, right? So we think about sanitation is not a value added process, right? Our consumers are not going to pay more money for our products, for our processes, because of sanitation. So we want to try to minimize the impact of that, right? We still have really high standards that we've got to meet, but we want to do them as efficiently and effectively as possible. Just like in your kitchen, you want to get in and out of that space as quickly as possible, but you still want to have clean dishes and providing safe food for your family. So yeah, the next one I wanted to highlight was get into one of the specific questions, and actually a couple of the specific questions as we move forward here. So the first one is related to a question around cleaning method. And this is really where I start all of my discussions, even at the highest level of the organization, when I'm with, directors, VPs talking about project kickoff and approval for capital dollars. My key questions are, hey, why are we cleaning and how are we going to be cleaning? Because that's going to have a huge impact. It gets into questions like, hey, is this new product going to be a different allergen profile than what we've run before? is there something new and unique about the formulation that's different, right? I know years ago we got into Greek yogurt, and Greek yogurt handled very differently in our systems than did our traditional product because of the higher protein content. We went to zero trans fats. As we go to different formulations, there might be different impacts, and we need to understand that from a design standpoint, from the facility and equipment. And then understanding, hey, what kind of cleaning methods do I then need to be able to meet the standards of clean? The challenges around sanitation become more and more as we go forward. Like they keep asking for new and unique things, right? There's, hey, I want to make an allergen-free claim or a gluten-free claim, or I've got to do kosher, halal, I've got to do organic. There's just all of these challenges and cleaning standards that we've got to meet. So we got to understand, where is it appropriate to maybe do a dry clean versus a wet clean versus something in between. So I want to get into a specific example here. You can see the picture here in one of our process areas. So let me set the stage here for you. This is a baked granola product. You can see, let me use my annotation as well here and do a draw. You can see over here is delivery of dry ingredients, specifically oats. So that feeds up and across over here and then down into this horizontal bar mixer. And then that then feeds to the forming area and into the oven. So this is a baked product. And then if we do have some trim or product that didn't meet our specifications as far as size or whatever, it can come back through the system into this regrinds area. So it can get ground up and fed back in as refeed. So I'd like to get your thoughts on, what cleaning methods would you employ in this type of area? So I've got, dry ingredients coming in the top. I also have some slurry that's mixed in at the mixer level. And then I've got this, baked granola bar that's just ground up and fed back in. So do you have some thoughts on what you might want to design for and manage for cleaning methods in this space? And like I said, chat, come off mute, whatever works best for you. Type in text over the top of my pictures. So I'll clear mine out of the way and clean that up a little bit. Any comments on what we can start with the mixer, right? So we are bringing liquids in there. So generally we think about using wet methods for cleaning. So we've got to, think about designing that area for control of water and wet processes. One of the challenges that we have here, and one of the reasons I brought up this example is, hey, this is a wet space, but it's kind of a mismatch here between this and these other two areas that I mentioned, right? So ideally, I would not bring water into the equation for these other two areas, right? I've got oats that are a low water activity, low moisture ingredient. Why would I want to wet clean that? I really don't have a reason to clean those on a regular basis. It's a really stable ingredient. There's no allergen changeover there. There's no reason to really clean that on a regular basis. You can see here, there's a super sack station that's going to deliver to that incline conveyor. Unfortunately, this was an add after this system was installed. They used to add this more manually to the mixer. But the implications of this being installed within that same space as the mixer is now that there's overspray and that whole area gets wet. So they eventually end up wet cleaning this as well. If I were to go back and utilize a tool like we're talking about today and really challenge, hey, what is the design and what are we going to set ourselves up for success for? I would have moved this over on the other side of the wall or created more separation here with a wall so that that does not have to be regularly cleaned. So now I'm wasting resources, effort, cleaning this on a regular basis because of its proximity to the wet clean process. So Again, I don't think there's a good reason to clean this on the regular basis. I would keep it dry and isolated and have some type of wall there. Same thing over here with the, let me switch to my mouse here. Same thing over here with this regrind system. That's also a dry process. No reason to clean that really on a regular basis. And I would want to keep that dry. So I would have, physical isolation between these two spaces and this process. And those are the kind of things with the tool that we want to call out. And as we think about, the contractor and doing the drawings for the area, how do we identify these spaces and get agreement? Hey, we need drains in this space because we are wet cleaning. We need the floor sloped. We're going to have to spend more dollars for control of water and, electricals that are going to handle that wet wash down versus my standards are going to be much different here and maybe not as aggressive around the sanitary design and again, keeping that dry and maybe having to do some vacuuming, brushing infrequently in that. I also have another picture here that's a little more of a close-up of this regrinds area. So the picture is taken from the perspective behind the mixer looking over this way. So I'll show you that one next. And you can see this is during sanitation. So my mixer is here to my left. This is the regrind station. They're dumping the tote of regrinds. It comes up here and gets ground up. But unfortunately, like I said, they're doing wet wash downs. You can see the gentleman here with the hose. You can see the steam. This room was, the floor looks pretty flat. So there's standing water. You can see the steam. It's not evacuating that steam very well. So a lot of times we change conditions during sanitation quite dramatically, right? You think about the process as pretty dry, an oven going, we're baking granola, and then all of a sudden I shut down the system and bring in, maybe high pressure or high volume water, or hot water, there's steam. Now I'm getting, maybe condensate on these overhead pipes and creating all kinds of undesirable conditions there. So would anybody like to make comments around what they would have maybe done differently as far as executing this project and doing anything different there? And I don't know if I'll see the comment, so I'll trust that somebody's going to tell me that comments come up here.
Karl?
Yep.
Separating the dry and wet equipment by walls, barriers.
Yep.
So, also, Aiden says, select a space with drains on the floor to work in.
Right. Absolutely. And then one thing I'll mention too, as you continue to review those, is ventilation. So just like in your kitchen, right? I'm boiling water on my stove. I would expect that I'm going to have good ventilation to pull and draw that hot, humid air out of that space so it doesn't condense on overhead cupboards or that kind of thing. Same thing here, right? I should be able to change my HVAC appropriately during sanitation and evacuate that hot, steamy air and get that out of there, because moisture, and you'll see that as a common theme from myself, is really controlling water. And if you've heard me speak before, the whole concept of war on water. Water is a key risk for us for many different standpoints, right? Obviously growth from a bacteria standpoint, but also, water is definitely an enemy from an equipment reliability standpoint, having to deal with it from wastewater. This poor gentleman's now got to wear, special PPE for dealing with water and chemistry. There's a high risk of slips and falls with this wet environment and all of those types of things. So a lot to consider here. But again, we want to be really transparent with what's going to happen in this space, not just during normal production, but during downtimes, planned downtimes, and how are we going to manage this space for not only sanitation, but maintenance activities or whatever might be happening, bringing in ingredients, all those types of things.
Karl, what is the downtime when you have to do a clean like that?
Yeah, so unfortunately, as a lot of people on this call are probably aware, very extreme differences, right? We could go from a system that takes maybe a few hours to clean to, in some of our cases, it's days, right? It can take 40, 50 hours to do a full line cleanup because of the size and, unfortunately, the mismatch between cleaning methods and design of equipment. I look at comparatively the design for meat and dairies type environments where we're cleaning every night and the systems are designed to match with the cleaning method. Yeah, they can turn those over pretty quickly every night. And then, unfortunately, in a lot of, especially older systems, older assets, not designed for either wet cleaning or dry cleaning, we can get into, days of cleaning. So I truly believe that it's the lack of focus of, how are we going to design the space and design the equipment to match with the cleaning method. So it really comes down to facility and equipment design to see a significant reduction in changeover time. And that's what I want to get across today. Oh, go ahead.
Just for the people in sales who are watching, would that mean that General Mills is in the market for an entirely new system?
Absolutely, right. I propose this all the time. I believe in a lot of these type of bakery systems, low moisture, low water activity environments. I could, if given the right resources, and including people, engineering, and budget, I could definitely see a 10x reduction in cleaning time, right? Wow. So if given that granola bar line, that takes me, this one not specifically, but a cold form chewy granola bar line, for example, takes, let's call it 40 hours. There's no reason that couldn't be cleaned in 4 hours like we see in a meat plant or a dairy type plant. It all comes down to designing the equipment. And I don't believe that needs to be full flood clean. I believe that we could do that dry cleaning given the right accessibility, following on quick changeover principles, all of that type of thing. So there's a huge opportunity. And I'm going to get into, that's a great lead in. I'm also going to talk about a metric that I'd like to see us utilizing to help drive that, because I truly believe that to drive down risk, we need to focus on reducing time and resources. If I can design out complexity in the process, I'll guarantee you that my risk will go down from a food safety standpoint, from a human safety standpoint, from an equipment standpoint. All of this complexity leads to, as you guys have probably seen in your own plants or projects, when somebody goes running around with a hose like this, it's going to cause a lot of issues. So if I can control that process and environment much better, I'm going to reduce the risk and the cost to the business. Okay, so let's dig into a little more detail. We were looking at the more of a macro level at that processing area. This is a similar type area, not the exact situation, but here's a stack up of again, a horizontal bar mixer. You can see that down here. This is the top of the horizontal bar mixer. Then we have a slide gate to stop flow of material. Then we have like a butterfly or pancake valve up here, also for metering flow, because we're dumping in flour or other dries into the top of that mixer. What do you think, if any issues would you see in this type of stack up as you think about my discussion around controlling the environment, thinking about cleaning method? Any concerns you have with managing this type of space and these components? And you can annotate or point to them. So again, at a macro level, we talked about putting up walls and isolation and controlling the moisture. It's the same thing here, right? We talked about that mixer probably is going to get flood clean. Somebody's going to walk out there with a hose and spray everything down. Is that really isolating the cleaning process? And are we keeping the moisture out of these other spaces? Because, hey, flour and flour delivery systems are very dry. So now I have this, yeah, exactly. So you can see there's a fabric sock between the two. And you can kind of see that maybe looks like it's wet. Maybe there's some mold on it. So that interface there is not a good isolation of dry versus wet processes. So I'm going to take you a level deeper and show you what it looks like dismantled. because somebody brought this. This was a project I was working on, and I had them dismantle this. So now this is the slide gate. And unfortunately, you can see the nastiness that's inside of there, right? We have dough, mold, just nastiness built up in there. Unfortunately, this was a big deal to take this down, right? If we go back to the previous picture, this was not designed to regularly come apart, right? It doesn't match with the cleaning, right? I want to keep this flour area clean or keep it dry. I shouldn't really have to clean it very often at all. But because of the migration of moisture from spraying water, from the steam coming up during that cleaning process, now I'm getting this what should be a dry component and area, getting it wet. And then I had to take it apart, right? So now it's up at elevation. It's probably a heavy slide gate here. I've got to unbolt all of these nuts and bolts. It's just a really bad situation. But it needs to be addressed, right? Our food safety standards are very high. We don't want to have, spoilage organisms or, heaven forbid, a pathogen showing up in this type of space. But it's very conducive to micro growth. So we've got to address that. So thoughts on, what could we do to mitigate this, or what would you have done differently in the project to make sure we didn't have this issue?
So Karl, Suzanne says, protecting that fabric in the design phase would have been a good idea. And then M. Couturas, I don't know the first name, says it's important to choose equipment suppliers who are going to be engaged with you from the beginning of the design process and who have that expertise. So it's a collaboration so that this doesn't happen. So I'm curious, who should bear the burden of the design?
Right. It's an excellent point. And that's why I talked about it. It's so important to bring together that cross-functional team and to identify these type of potential mismatches, right? Whether it's, hey, I'm going to have an allergen here and a non-allergen here, maybe two production lines, or I'm going to have wet cleaning here and dry cleaning here. How do I separate those? Just like in your house, right? We have very clear isolation. Like, I know that I'm not going to put carpet into the kitchen. I'm going to have walls that separate my bathroom from other, cooking spaces or other spaces in my house. So identifying those on the drawing would be great. And then getting into the level of detail for this situation, the one person mentioned that cloth sock. Well, obviously you don't want to get that wet. So do I pull that off before the cleaning process? There's other socks that are made out of different plastics, polymers. Could I use a different material? Could I isolate it by getting it further away from the mixer? Could I have a spool piece or a jumper in between? So I've got space as my separation. But you've got to come up with a solution that you can keep that area from getting wet. Otherwise, I've got to clean it. So that's my next solution, is either I keep it completely dry and isolated through some creative methods, or I've got to design something very differently. Here's an example. One of our plants fabricated this themselves. They came up with a very simple slide gate mechanism that hooks up to a hydraulic component that opens and shuts this, but you can see the quick disconnects, very simple components, so that they can, lighter material, so they can take that apart and knowing that it's going to get wet and dirty because, hey, it's so close to the top of the mixer, there's going to be backsplash as I'm mixing, that kind of thing. So I've got to be able to clean that. But then there's commercially available options as well. Here's Peerless's slide gate valve, right? So very nice design, simple components, easy to dismantle, no tools, just hand or toolless releases, and I can take this apart and clean this and manage this offline. Like, I can take it to a wash bay and clean it with a dishwasher or by hand or a COP tank, whatever that might be. So again, designing for the conditions that we're going to expose our equipment to, you've got to think to this level of detail, and especially those interfaces where we have a wet dry interface even within equipment. Even for, you think about that mixer where you have the oil drop or even the water drop coming into the top of the mixer. You get backsplash and dough and flour up into that. I've seen, I should have included that picture. I had a pipe that came up off of the top of the mixer to deliver water and made a turn, a 90-degree turn. And I took that pipe apart and there was mold backed up into that pipe, probably 3-4 feet, even though it made that 90-degree turn right away, and it was just delivering water to the top of the mixer. So you've got to think about where is that interface between wet and dry. And again, not only from a sanitation standpoint, but from a maintenance and operation standpoint, I've seen things where it gets so plugged that the material's not metered properly, or we get back pressure on a pump, or it could be a conveyor belt that's not tracking properly. There's lots of implications to not thinking about what happens if soil builds up, or we run into these sanitation cleaning challenges. So the next concept that you'll see, another example, again, I'm just cherry picking a few examples off of this checklist, but another key thing besides understanding the cleaning method is access. So regardless of cleaning method, I've got to have access to it. So the question here is equipment accessible for cleaning all the way around, not only for cleaning, but inspection? And then, as I mentioned earlier, can I highlight those key access points throughout the facility for routine sanitation and maintenance on the project installation drawings, right? So I'm going to show you some pictures here. So talking about, hey, let's understand on an ongoing basis, where am I going to need to access, right? Is it going to be some that's at elevation? I need a ladder or a mezzanine. Is it something I need to get under regularly or around for, again, maintenance and sanitation activities? So here's a couple of pictures with a couple of different pumps. Yeah, do you see anything good or bad in either of these pictures as you think about, having to perform sanitation or maintenance tasks in these spaces? So you can see here on the left, we have a diaphragm pump. Unfortunately, it looks like it's kind of crammed in here. There's maybe a tank here. There's a gate here in the way. So it'd be very difficult to get in here and dismantle and clean and do maintenance activities, right? The pipes are very close to the floor. How do I clean up? You can see there's some material, maybe some vegetables and things that are laying on the floor. How do I clean, squeegee, all of these activities get in there, right? Yeah, there's this, the guarding there is very close. Oh, yep, go ahead.
We have a comment. Yeah, the right is absolutely easier to clean.
Right. And that's not perfect either, but definitely, I've got the pump and the motor up off the ground. It seems to be a little bit better set up for being able to, if I do need to spray down the floor or get under there to squeegee, it's a little better set up. The pipes seem to be a little higher off the ground. I still worry about, people trying to walk underneath those and get into these spaces to do their activities. But, significantly better scenario there. But again, we got to talk about these and it's never going to be perfect, right? But we got to understand where we're willing to give and what we're going to need to manage on an ongoing basis. And this can be significant implications on time, right? If I got to try to get into this space and dismantle and clean this regularly, I'm going to have to account for a lot more time and maybe a higher skill set to get this work done than if I would have designed it differently and more thoughtful up front. Here's another example on a project where these conveyor belts were installed to deliver, in this case, it was pizza crusts. Unfortunately, they're at elevation, so it's maybe 7 feet up in the air. This one especially is really close to the wall. I don't have this in the picture, but the motor was on the wall side. So it would be very difficult for replacement and pulling the drive shaft for maintenance as well. So just a lot of issues with cleaning, inspecting, and maintaining this situation. And actually, in this one, there was an extreme where we had to have USDA inspection here, and I had to get creative with them and help them, and I had them use a GoPro camera on a selfie stick to get up here and kind of videotape and do inspection from afar, to be able to be comfortable that the system was clean and ready for startup and pre-op. So we want to avoid those type of extreme situations. So again, understanding, obviously they wanted the conveyors up out of the way, but how do we balance the needs for normal operations as well as sanitation and maintenance? Another unfortunate situation that happens more often than not is we don't think about the layout in regards to access to floor drains, whether it's, hey, I got to do regular cleaning, or maybe there's a drain backup and I need to get to a clean out or something like that. So you can see here this raised platform or mezzanine was installed here, and there's a drain underneath there. So this one actually led to some listeria issues. But it's very difficult to get in there and clean and maintain that with the proximity to the equipment and the decking here. So really important to lay out those critical spaces that need to be addressed on a day-to-day basis or on a regular basis. Another example, just in a packaging area here, you can see the pallets being transferred to the system. Probably did a great job at the FAT and making sure that the equipment did what it was supposed to do, and the design met all of our needs. But then we get to the point of installation, and that's where things can go awry. In this case, now we've got conduit, all these utility lines and things that now are limiting access. If I need to sweep or get underneath this piece of equipment, I've got these, almost like jail bars blocking access to some of these key points. And I see this more often than not where, yeah, everything looked beautiful during the factory acceptance test, but then you bring in and work with your installers and your contractors, and they don't understand the implications of running conduit in certain areas or putting wire baskets or whatever, and utility lines, all that type of thing. So that's the level of detail. Is we just want to, with this tool, help facilitate those discussions up front. We know it's not going to be perfect, but it's a give and take, and understanding, hey, what we need to get in here for cleaning. How do we design this and make it as accessible as possible so we don't waste time and resources during changeovers and those type of activities. So the third concept that I wanted to go over was around containment. Right. So thinking about, especially during construction activities, there's a risk of physical hazards. Right. So one interesting word I stumbled upon at one time was swarf. Has anybody ever heard of this term before? Kind of a funny sounding word, but it's really just a term used to describe fine chips or filings of metal or other material from the machining process, right? Which can be a huge problem. If I'm doing cutting, grinding, especially out in the production spaces or anywhere near that, we want to avoid getting those materials into our product, obviously. And we don't want to count on our metal detectors to try to pick that up. That's not the right controls in that instance. So just remember that funny word and the controls we want to see. So what are some of the things that you think about? How would you control, making sure that we don't get, foreign material into our processes during construction type activities? Anybody got any ideas on that?
Magnets, Suzanne Donaldson suggests.
Okay. Yep. We can have magnets. On our systems, we can have sticky mats for people walking across if we're going from a high risk area, like somewhere where they're doing cutting, grinding into back into the construction zone or into the production spaces. And then I got some pictures here for isolation of these spaces, right? So how do I isolate this space? A lot of times I'm still having to run production activities. So I've got, curtain this area off, creating vestibules, all those types of things, all the way, even up to the ceiling, right? Sometimes I've got to think about controlling for air movement, and making sure that, I am negatively pressured inside my construction area, and that does not become a problem. So a lot of thought needs to go into this, and it's not a cheap process, but we need to budget for it, right? So that's part of this tool, is facilitating discussion and make sure we're not surprising anybody. Hey, I need extra money for isolation of maybe there's production going on and I got to isolate construction from regular production. I've got to think about extra sampling or extra cleaning that needs to go on afterwards. So being very transparent with our cross-functional team around the implications of a project like this, and not coming in at the end and being like, oh my gosh, you guys didn't do this. Well, we didn't talk about it and we didn't budget for it, and we don't have plans for that. So we've got to be upfront with our partners about our expectations there. And then another concept, so kind of outside the risk standpoint, is again minimizing labor, and that by that I mean minimizing complexity of our processes. How do I design so that I can minimize the skill sets needed, the challenges that they're going to encounter, right? So I use this valve example. What seems to be a very simple shutoff valve, if in a certain situation, can become very complex to manage, right? So think about, hey, there's just a valve in a pipeline and I turn it on and off and I don't need to think about it, versus maybe I'm running an allergen product, or there's a big sensory difference, a flavor, a color that I need to clean thoroughly for. And now I got to dismantle this thing and clean it. Boy, that's a lot of risk, taking even something as simple as this valve apart into the component level. You can still see, even though this was supposed to be clean, the material build up on this, and then the risk to damaging some of these gaskets and seals and components and O-rings and that type of thing. So imagine scaling this up now. Very rarely do we see a system with just one valve on it. There's a lot more complexity. And as you think about, wow, the amount of labor that it takes and the skill sets that it takes to take something like this apart and put it back together properly. So addressing that up front and planning for how much labor and complexity and skills do I need to manage that new system, that new process, and can I work with my OEMs and my vendors to minimize that, right? Could I do something different? I know I've got to clean this regularly. Could I come up with a more simpler option, a simpler, shut off valve that's just a few pieces, and could, quick releases, and those types of things. So this is a very simplistic example, but think about this on a more macro level, and how that time adds up very quickly in our processes. And we end up with, all of a sudden, it takes 40 hours to clean a system where it could have maybe gotten to be done in 4 hours if we would have designed it correctly. So this is where I want to introduce you to this concept of, key metrics and success criteria related to project work, related to sanitary design. So the metric that I'm trying to introduce and talk about is, changeover labor minutes per unit operation. So how much time and labor does it take me to do the activities that I need to get the system back up and running? So, in some cases, I talk about that 10x difference, right? In a packaging area, for example, on making some of our pizzas, maybe it takes a few hours to clean with a couple of people. Let's call it 8 labor hours. Whereas that same type of system in a granola bar system takes 10x that time, because it takes, like half a dozen people, and it takes them hours worth of work, right? So it's like 2 people for 4 hours is 8 hours total labor, versus, 8 people, 10 hours is 80 hours, right? So 10x the time, because of all the extra people and all the extra time that's needed there. So how do I make that very transparent? How do I push back on my team initially to say, hey, as we think about purchasing equipment, as we think about designing that facility, how do I think about minimizing the labor minutes, not hours? I don't want to talk about hours. I want to be very transparent that we want to control this down to the minute. At a unit op, oops, sorry, bump my keyboard there. At a unit op level, and really understand the implications there, and not just from a sanitation standpoint. There's a lot that happens during, planned downtime, right? I got to shut down the system and empty of material. I got to dismantle. I've got to clean. I've got to inspect. I probably got to do some maintenance, PMs, right? Preventative maintenance work. I got to reset up the line and get it prepared and ready to make the next product. So all of those things take time away from making product at a significant cost and implication. So I want to make this transparent and push back and say, hey, you're delivering me a piece of equipment that I'm estimating is going to take me, one person 8 hours to clean. How do we get that down to being one person 4 hours to clean? There's some basic concepts that I push that we're not going to be able to get into a lot of detail today, but quick changeover principles and basic principles around design that says, for example, let's not design equipment that needs 2 people to help clean, right? I want to make the guarding or the parts and pieces light enough that one person can handle them. I don't need to go get a friend to help dismantle or take things apart and lift guarding and move parts, that type of thing. I'm taking them away from another job and just adding risk to that process. So this is one that I think is very marketable as you think about pushing, hey, we're going to help you drive out plan losses in your system by designing correctly and following quick changeover principles, those types of things. I mentioned up front that I'm a big proponent for this war on water and controlling water in our environments. You can see the picture example that I've got here is an unfortunate situation where we've got a bakery. We've got a mixer in this other room. They tried to do some containment. They've got some walled off areas between this mixing area back here with this trench drain and then into the sheeting area. But unfortunately, they didn't completely close this off. And now you've got water running into, you can see the dry flour on the floor, but it's now running across into the drain in the bakery area. So now I've got that disconnect of a wet dry zoning not working out, and the implications there are pretty high related to micro growth or slips and falls, all that type of thing. So I just want to highlight again, I'm not going to go through all the deficiencies that we can see in a project, but poor water management's a key hot button for me. So I don't want to use